Let's look at the calculations for the leftover aluminum wire lab. So I've gotten to the point where I'm at my data table. Go up a little bit so you can see the lab just in case you were not sure. It's the leftover aluminum wire lab. We finished the lab. We've collected all of our data. Now this is the data for those of us in GATE. Those of you who in cohort A and B, you'll have slightly different numbers, but all of your calculations are done the same way. Remember, I collected the final data, this 0.57 grams and 0.63 grams. That was the mass of the leftover aluminum wire, as well as the 25.67 and 25.86. That was the mass of my evaporating dish with that copper that was in it. So now I want to walk us through doing the calculations. Now, as I talk about this, I also want to show you where this fits in. When you're doing the lab, remember we went over this last time, the balanced equation. We went over the evidences that the copper 2 chloride was the limiting reagent. We went over possible sources of error in this. And I really can't address this one yet until I see our results to know where the data lies, the errors lie in this specific data. And we talked about over 100%, why we use a certain limiting reagent. I guess that was the last one. And why we add one of more than another. So these were all things that we have already discussed when we did the lab. So the last thing I want to do is I want to address questions 2 and 3. So right now I'm addressing question 3. Question 3 says complete the data table. Most people do that, but this is where they go wrong. They miss this point that says show all calculations on a separate sheet of paper, clearly indicating where each result came from in box A through G. So what that means is you're going to need to show all of your calculations on a separate page. Now, you don't need to show the setups. I'm showing you the setups, but you need to show the numerical calculations. So what we're doing here, and then you're going to do trial 2 as well. So I'm going to show you trial 1. You have to show trial 1 as well and trial 2. I'm just going to leave it up to you to do trial 2 on your own. So trying to be clear with this, for question number 3, you need to show your calculations, the number values for trial 1 and trial 2. You do not need to show the word setups, but you do need to show trial 1 and 2. So the first thing I have here is the mass of aluminum reacted. So to do that, I'm going to take that 0.70, that was my mass of aluminum wire that I started with, subtract the leftover piece of wire, 0.57, and I get 0.13 grams. That number goes into my data table right here. Show that set of calculations as well as trial 2 when you show your calculations. Okay, so be sure to complete that for trial 2. Next one here says mass of recovered dry copper. So I basically took the mass of that evaporating dish from today and subtracted from it when it was empty. So I took 25.67 minus 25.35, and I got 0.32 grams. Remember again, I'm showing only trial 1. You need to show trials 1 and 2. I just don't want to do all of the work for you. I think that there's some value in you doing some of this on your own. We now move down to the next one here, moles of CuCl2.2H2O. I kept this boxed from last time to remind you that the copper 2 chloride was in the hydrated form. Because it was in the hydrated form, I needed to find the molar mass, and that's 170.5. That accounts for 2 waters. So what I do is I took the mass of the copper 2 chloride that we started with. Okay, that comes from right here. That was your 0.5 grams. Whether you use 0.5 or something near there. So for trial 1, I use 0.52. When you also show trial 2, be sure to put in the 0.5. That's why I have a trial 2 here for you to do that. 0.52 divided by 170.5 is, now I only have 2 sig figs for the 0.52, so 0.0030 moles. That number goes in here. Next one is the moles of aluminum that should react. This is stoichiometry. So we use the balanced equation in that 3:2 mole ratio. So again, remember, don't forget to show trial 2. 0.0030. I take that 0.0030, multiply by 2, divide by 3, and I got 0.0020. Don't forget again, I'm showing you trial 1. You need to also show trial 2. Okay. So we have the moles of copper. We now also have the moles of aluminum. On to number 4. Number 4 says the mass of aluminum that should react. So we take those moles that should react. And every 1 mole of aluminum, 27 grams of aluminum. Oops, it's canceling out the AL moles, not the 20. So times 27 equals, again, only 2 sig figs, 0.054 grams. Continuing to fill in my chart. I move down. Again, I'm showing you trial 1, also show trial 2. Show trial 1 and trial 2. We're going to show both of those when you're submitting your work. And again, no word forms, just numbers. I go on to number 6. What is the percent error? So what was the amount of aluminum that reacted? Well, I'm going to have to go back up here. So let me find that aluminum that reacted. Let's see here if I can find it. We did this somewhere here. Where did we do it? Number 1, mass of aluminum reacted, 0.13 grams. All right. Went a little too far. 0.13 minus what should react, 0.054. All over 0.054 times 100. Now, when you do this, you're going to find that there's significant error in this aluminum. And this goes back to that fact that when we put the aluminum in, you saw all of that bubbling. That bubbling was aluminum that was reacting with hydrochloric, well, not hydrochloric, but with the acidic solution. So, and even in the beginning, we actually took that aluminum wire, we rubbed it off. If you took the mass, I think we took the mass after the oxide was taken. But again, there's a tremendous amount of mass lost from that acid reaction that we don't account for because it's a side reaction. So we take the 0.13 minus 0.054. That gives me only 1 sig fig divided by 0.054 equals times 100. And this is a huge one. It is a 100% error. That's a lot. But again, not surprised because just the method of the lab, more of it is going to react than what we think is going to react. And even when you scrape that copper off, sometimes the aluminum comes with it. So no big deal there. That's to be expected. You're going to do the same thing. Actual mass of aluminum reacted. Remember, that comes from number 1. The mass of aluminum that should react, that comes from number 5, right? And then the mass that should react, number 5. And that's where we got our numbers for our percent error for aluminum. Okay. We get our percent error for aluminum. We can now look at the copper. What's the predicted mass of copper? So now the copper 2 chloride, if you remember, was the limiting reagent. So I'm going to use the moles of copper 2 chloride to find the mass of copper 2 chloride that actually reacts. We got to go all the way back up here to find those moles of CuCl2. Boy, that was all the way in number 3. I believe it was, right? So number 3, that was 0.003. Right, so this moles comes from number 3. Our number in trial 1 was 0.003. We take that 0.003 times 63.5. And again, I can only use 2 sig figs because of the 0.0030. And I got 0.1, let me make sure my number's right here, 0.19 grams. So I should have had 0.19 grams of aluminum that was reacted. I'm going to go down and start putting these numbers in because I've gotten a little bit behind here. 100%, 1%, predicted mass 0.19 grams. Now, if you remember, we got 0.32. That's a lot. Now, the reason why we got so much is, number one, it's probably still wet, very likely. And then number two, it's also likely, well, we know for sure because we saw it, it was oxidized. So when we go down here for, again, remember, show number 6, show that trial 2, show that trial 2 for number 7, percent air, the mass of recovered copper. Remember, this one comes from, I believe it's number 2, the calculation. There it is, yep. And then the predicted mass, that's number 7. And so let's put those in. The mass that I got, I think we said was 0.32. Woo, that's a lot. Okay, 0.32. Minus 0.19 all over 0.19 times 100. First thing I do is I subtract, and 0.32 minus 0.19 is 0.13. That's 2 sig figs divided by 0.19 times 100. 2 sig figs is what I'm limited to. That is a 68% error. I'm going to go back up here. 68%. My last one then is my percent yield. Remember, percent yield, it's basically found like you do your grade, what you got, 0.32, over what you should have gotten, 0.19 times 100. Now remember, when I do this, 0.32 is only 2 sig figs over 0.19 times 100, and I get 170%. So 170% yield seems very, very bad, but you got to remember, just a very small amount, just a few drops of water will affect that significantly. And so this is 170%. I did all of the calculations for trial 1. You will need to do them for trial 2 as well, not only to fill in the chart, but also you'll need to show me. That's how I figure out if you made a mistake, where it was at, and so I can correct that for you. Okay? So we've done question 3, which was basically to fill in that data table, doing all of our calculations. Question 2 says, which starting material was the limiting reagent and which one was in excess? Show by calculation. So we're going to pick a trial. Doesn't matter, trial 1 or 2. I'll pick trial 1. And what we're going to do is we're going to start with copper 2 chloride. And we're going to start with aluminum. Now, I got to look at my numbers because I don't remember how much aluminum we had. We started with the mass of the wire, 0.70 grams. And we're going to prove through stoichiometry that the copper 2 chloride was all used up. Well, copper 2 chloride, remember it's a hydrate, is 170.5 grams for 1 mole. Again, remember we're accounting for those 2 waters. You got to account for those. For every, now we go to our equation, looks like we got a 3 there, so for every 3 moles of CuCl2, now I can convert to any product, it doesn't matter. I figured copper since we already solved that. But if you solve for AlCl3, that wouldn't be wrong either. You just choose a common product, the same for both. 1 mole of copper is 63.5 grams. And what we find is 0.52 divided by 170.5 times 63.5 is, as we said before, 0.19 grams. Go to my last one here, aluminum. 27 grams of aluminum, if it were the limiting reagent, is for every 1 mole of aluminum. The reaction shows 2 moles of aluminum for every 3 moles of copper. And 1 mole of copper, 63.5 grams of copper. Now, if all of the aluminum was used up, 0.7 times 3 divided by 27 divided by 2 times 63.5 to 2 significant digits is 2.5 grams. Notice, evidence, mathematical proof that copper 2 chloride is the limiting reagent. So that's what it means here is show your calculations and all work to determine this, This is what we mean by showing you proving which one was the limiting reagent. Okay, I think we've gone over everything. You can see that we have I'll start again with the data table. We have the data table filled in. You need to fill in trial 2. Don't forget that. We showed our calculations. We only needed to show, I showed you where they came from, but that was just for your purposes. You just need to show me the number calculations, so everything on the right-hand side for trial 1 and 2. Make sure to get those sig figs right. There are 8, 9 calculations. We answer question 1 with a balanced equation. We answer question 2, the proof of what was the limiting reagent, copper 2 chloride. We answered question 4, what evidence do you have? And we went through that evidence. Your error analysis. Well, we have high results. So 5 and 6 will go in tandem here. That's awesome. Copper was wet more than likely, and we know it oxidized. Both of those give us high results. And I would assume you probably will have high results for the second part of the lab as well. Now, if you have high results, then in number 6, say C number 5. Okay, it works out very nicely. If you have low results, well, unfortunately, you'll have to add those low results as well. 7, why do you think we add excess? We answered that question. And then why do we choose the limiting reagent that we do for a reaction? Okay, that's the end of the video. Hopefully that helps. Hopefully we can get all of these calculations done and everything done in a correct manner for when we turn it in next week. Okay, leftover aluminum wire lab.